Hello, my name is Luis Lozano, and I will explore the data and create a machine learning model using Python in Google Colab. So first, I'm going to import the libraries I'm going to use. I actually didn't use NumPy, so I could drop it. I'm going to leave it there. I use pandas, matplotlib just to check or visualize the relationship between the variables, as well as Seaborn it has a lot of functions that work pretty well with the visualization also. And I'm going to check the correlations there. And I will try to use linear regression with the mean square error and the R2 score for the metric. And then I'm going to compare the linear regression with a neural network using Keras and TensorFlow. Just a small feed-forward neural network. So I will begin with the exploration. As it was said in the Coursera website, we have these columns: the temperature, the exhaust vacuum, the ambient pressure, relative humidity, and net hourly electrical energy output, which is our target. So I first read the CSV file that appears in the Coursera project website. And then I check the first 5 columns and the first 5 rows, sorry. And we see some values, right? The expected, the net hourly electrical energy output, the PE variable, which is our target, is continuous, so we have to use a regression model. And I see the shape, so I see that there are 9,568 rows or observations, 5 columns. So it is pretty quick with pandas to check the correlations. And here we have them. As we can see, the correlations are pretty high and low, well, or negatively high. With the temperature, with the exhaust vacuum, with the pressure, more or less, not so high, but 0.51 is really high compared to different projects I have been working on. And 0.38 is also high, a little bit high. Okay. And we can also see that we have a correlation between the temperature and the exhaust vacuum of 0.84, which is a little bit high, as we can see here in this plot. On the right side, we can check that yellow, pretty high correlations are more or less yellow, and this is the 0.84 value we had here before. And also colors that are pretty close to the purple one are very high, and we can see them as a negative correlation between the temperature and the PE, and as well as the exhaust vacuum with the PE. Okay. So I also plot here some other relationships between the variables and the target. These are scatter plots. And also scatter plot between the temperature and the exhaust vacuum, which were highly correlated, and we can see that they are positively correlated there. Just by having these results, I'm not going to drop them because we have a risk of having too little features. So instead of having just 3 features, I will try to use the 4. In practice, when you lose one of the features, you still have another one that can keep working on your project. Okay. So now I split the data sets. I use 70% for the training set 10% for the validation set, and 20% for the test set. So since this is just an exercise, I could have them fixed. I won't do any cross correlations, cross validation. And this is the way I split them. I found here the first 70% and then the first 80%, so I could split there. And then I keep moving. I create the linear regression. I fit with the training values, and then I predict on all of them. I obtain the weights of the linear regression. And as you can see, here are the values I found. So the mean square errors are not so high, and the R squared score seems pretty good. 0.93 for train, 0.92 and 92 for the other one, validation and test. So they are not that bad. Okay, so it's like a really good model. So I do the same with the neural network. It is a simple feed-forward model, as I said. I define how many input variables, then how many neurons in the second layer, how many neurons in the third, in the fourth, and the final layer has to be only one, since this is regression. This is a summary of the model. And then I fit with 30 epochs. I checked this before. The epochs were like, for 20, they were not ready yet, but for 30, they went to the lowest value. You can see them if you are gonna use something like this in the future. Just put here 1, and you can see the losses. Here you define the losses. And you can also check the metrics, but I didn't put them here. And then I predicted, as I did in the linear model, I obtained the losses. As you can see, they are pretty low, but not lower than the linear regression. And I obtained, again, pretty high values for the R2 score, but not higher than those for of the linear regression. So given that this is a more complex model, here I put my conclusions. I decided to keep the linear regression. It is simpler and it gave me better results. Okay, so thank you and goodbye.